All right, I'm recording now. Hopefully you saw the announcement that I sent out. Let's go to the announcements. So today we're going to do review for test number 4. A few things I wanted to make sure you remember because I'm forgetting too. They're all sort of, everything's coming together at the end of the semester. I'm sure the other classes that you're in are also trying to wrap things up. Quiz 11 for Mod 11 is due this Wednesday. So we just finished Mod 11 last Friday. You should have done the homework. Again, the homework, I'll take the homework late, but you know, Mod 11 is the quiz is due Wednesday. Test number 4. So test number 4 is going to be Mods 9, 10, 11. That's what we're going to start review on this week. And that's going to open up next Monday at 6 a.m. And it'll be due Tuesday, 11:59 p.m. So you have a couple days to, you know, work it in there. It should only take you, again, it's an hour exam, but it shouldn't take you anywhere near that long. And then the final exam, so I was just talking about this earlier before I started recording. It's cumulative, but because we had test number 4 pretty much back to back with it, you're not going to find a lot of stuff from test number 4 on it. I think there's maybe a couple questions that cover these modules. I don't think there's anything from module 11 on the final. Maybe mods 9 and 10, but there's a question here or there. But you won't actually even need a periodic table for the final. The finals open on Wednesday, the 5th at 6 a.m. You got to complete that by Thursday, May 6th, because starting Friday, I want to start being able to get all the, you know, start putting all the grades together for all my classes. And I'm going to have to grade. I have some tests that finish up, you know, Wednesday and Thursday, so I'm going to have to start grading those as well. All right, let's go. Oh, you know what? Let me just go into the learning modules and show you the different folders. So down here, you'll see test number 4, review and test. Oh, I should have moved the final up. The final exam folder. So we'll go into test 4 in a minute, but the final exam folder, you click on that and you'll see just the information, right? It counts as 2 exams. It'll be available that day. You have an hour to complete it. Here's the reference sheet. The reference sheet for the final, you can see it's pretty much, it's pretty small. There's some significant figure stuff that you hopefully have memorized, or, I mean, you have your sig fig packets. But this is all you're going to need for the final exam. And that's in that folder. All right, let me go out. We go into test number 4 folder. All right, so for test number 4, the review sheet here is the same one we've been using. Let me close that. Same one we've been using. Oh, sorry, that's not the review sheet. This is the reference. This is the review sheet. Oh, not the reference sheet. The reference sheet is down here. That's what I wanted to open. All right, well, let's just call it the review sheet. This is what we're going to cover today. And I just put the dates in here again. Let's see. This basically summarizes what's going to be covered on it. And then we've got the questions for review, which we'll start doing in a minute. And then the reference sheet that you'll need is here. This has both the tables from chapter 9, right, for the ions and variable charge ions and the stem names, polyatomic ions. And then it has the periodic table, right, because this covers both the periodic table and chemical ions. All right. So let's work on the review sheet. I'm going to use a poll everywhere here. And I'll also write out the answers as we go. But I'm not going to do it for every question right in a row. I'll do a few online. Remember, for poll everywhere, you can join by going to this link, pollev.com/dsarajonis556, or you can text right? Text the number 22333 and text this this text in here. Text D. Sarajanis 556 to that number. So why don't you go ahead and join the poll? Those instructions are also located here in the folder. Everything's anonymous, just a reminder. So I don't know. I'm not gonna be like, oh yeah, I can't believe so-and-so got that problem wrong. I don't care. I mean, hopefully the idea here is to review the stuff, and you know, if you make mistakes, it's better to make mistakes here while you're learning it than on the actual test. So that's the philosophy of this poll everywhere stuff. Obviously, if a whole bunch of people get the wrong answer, I'm gonna be like, oh no, you know, it's mainly this is I'm emotionally vested in this more than you are. All right, let me go full screen and activate this. All right, according to Rutherford, the atom is made up of mostly what? Why is this timer not starting? Oh, don't tell me I gotta. It's activated. I don't know what's going on here. It's activated. Let me try. I'm gonna try texting in and see if it works. Oh, I gotta turn my phone on. So I don't know why the timer is working, but we'll do about a minute here. According to Rutherford, the atom is made up of mostly what? I might have to restart my browser. That's what happened last time. I don't know why though. All right. Maybe I should. Oh, looks like I'm able to text. Well, we'll see if this doesn't even look like it's registering. Let's see what the responses are. Oh, okay. Things are activated. Okay. Let me clear my answer because that was just wrong. I typed in A, plum pudding. All right. So according to Rutherford, the atom is made. I put in A earlier. Mostly of empty space. Yeah, empty space. Not plum pudding. Electrons and protons. Electrons are in the outer, outer region in the orbitals of the atom. So electrons are not actually. Electrons are the lightest of the components in terms of mass. Have the least amount of mass, and then protons have, well, same amount of mass as neutrons, but all the protons and neutrons are tightly packed in the center nucleus, right? So, and the electrons are really far away. Remember that example I talked about the football field? That if you put a penny on one end of the football field, that would represent the nucleus, and the atom, the electron was, or that would represent both the size of the nucleus and the relative size compared to the space. You got the first electron is a football field away from that that penny, so that's empty space. Oops. All right, is this going to work? Apparently the timer's not working. It's driving me insane. I'm going to close my browser and restart. I wanted to use the timer because I didn't want to sit here and time. So let's just try this again. So this should be active. There is the timer going. Okay. What's the main difference between the atoms of different elements? Number of neutrons, number of protons, electric charge, or none of the above? What do we got? Doesn't tell me how many responses I got. Oh, 11. There it is at the bottom. Number of protons, right? Atoms of different elements. So all atoms of different elements are neutrally charged unless they form ions. So we're talking here about neutral atoms. So typically when you're talking about something that's charged, it's called an ion. So between the atoms of different elements would be number of protons. The number of electrons is different, but that's these are all the atoms are neutral. So let's just look at the I got to get back on the Blackboard now to show my document. Periodic table. I want to pull that up anyway for later. Whoa, what's going on here? Sorry, I closed my browser. I forgot. It takes a minute to open this back up. Technical difficulties. We have the whole week ahead of us, though. We'll get this done. I'm hoping we'll actually be done before Friday. I could just use that as a Q&A day if you want. Physical science. Again, sorry about the browser technical difficulties. Don't know why Poll Everywhere is doing that. Yeah, so on a periodic table, we've got, as we go from element to element, right, we're adding protons. The protons are what define the element. So you can lose an electron and still be carbon. You should be a carbon ion, right? Or gain an electron, whatever it wants to do. You can have different number of neutrons, and you're still going to be carbon. You'll just be a different isotope of carbon. And then if you change the number of protons, that's what changes the actual properties of the material. That it makes it a different element altogether. This is why alchemists could never turn lead into gold, because they could never manipulate the number of protons. All right, next problem or next question should be pretty easy. Which two particles make up the nucleus? Here's your options. All right. What do we think the answers are? Oh, I forgot I have to show. Yeah, protons and neutrons. Everyone got this right. No need to discuss. Well, everyone who participated. What was that? 8 people. All right. What am I counting? 1, 2. I'm counting 23 participants besides myself. So we need to up the participation here, people. What type of electric charge does a proton have? So neutral, negative, or positive. So this is the actual proton itself. Oh, time's up. Sorry. Yes, positive. 8 people. All right, let's go to the next one. I want to see 10 responses. What type of electric charge does an electron have? Neutral, negative, or positive? I'm just writing this down in the notes and then we'll, as we go. I'll pull them up in a minute. We should go pretty quick through this first page. All right. Negative, right. 10. Ooh, 10 people. Hey. All right. Let's see if we can get 12. 4C. What type of electric charge does a neutron have? Neutron. Oops. All right. Neutral. Yes. This one is, if you're using the N to try to remember, this can be confusing. So neutral, neutron, you have to look at like the first 3 or 4 letters, right? Or 5. Neutron, neutral, right? You just replace the ON with AL, neutral. So it's neutral. And let's do the next one, and then I'll show you the paper. Which 2 particles in the atom have about the same mass? All right. Proton and neutron, correct. That's the, I forgot I have these. I think I have most of them the correct one. Yes, proton and neutron. Remember, the electron is very, very tiny compared to the proton and the neutron. Very, very small mass. Let me switch to my document camera, which apparently I've closed. No, there it is. All right. So just to recap, if you're looking at writing these down, if you've missed any of them, that's what we've got. Again, I will scan this packet when we're done and post it. So think about what the mass number is. I'm going to give you some multiple choice for that one. Let's go to the question. Define the mass number. So look at the options here. Okay, some of the protons and neutrons, some of the number of protons and number, yeah. So the mass number is the sum of the protons and neutrons in the nucleus. So remember, electrons are so tiny. They're about 1,000th of the mass of the proton or the neutron, that in general chemistry, we essentially ignore them. So the correct answer here is the sum of the protons and the neutrons in the nucleus. Let me switch to the document camera here. I need to put this different spot on my, how do I do that? There it is. All right. Sum of the protons and neutrons in the nucleus. I put the mass number equals neutrons plus protons. You're going to need to know that for your test, right? Remember the mass number is the number of protons and the number plus the number of neutrons, or sorry, number of neutrons plus protons. I wrote it backwards here. All right. Who is credited with discovering the nucleus? Why is this not working? Niels Bohr, Rutherford, Thomson, or Particle Man from the "They Might Be Giants" song. Hubert. Right. 8 responses. Not a lot of confidence here. Okay. No one said Thomson. Thomson was the plum pudding guy. One of you is toying with me with Particle Man. It was Rutherford. Yes. So these two are kind of hard to remember. Bohr was the one that came up with the model of the atom, but Rutherford was the one that did the experiments with the gold foil and determined that there's got to be some kind of concentrated nucleus. I'm pretty sure Rutherford was a student of Thomson. And so he went on to basically, Thomson sort of hypothesized this. And we joke about this plum pudding model, but Thomson sort of hypothesized it. And even he was not convinced it was true. He just was trying to make his best guess without any evidence at all. Oops, I want to do that. Go back to this. So Ernest Rutherford. All right, what's an orbital? Let's see the different definitions we're given for that. All right, so you got about a minute for this one. You have to read them all. Right. We got a bunch of options here. So we can eliminate this one because this one's talking about the nucleus orbiting the electron, and we know that's incorrect. The nucleus is found in the nucleus is in the center of the atom, right? And the electron is around it. The question is, how is it around it? Well, and maybe this is kind of a poorly worded question because the original idea had electrons following a fixed circular path. However, now we know that an orbital, what we talk about as an orbital, is basically the space around the nucleus in which an electron is likely to be found. So it's more of a probability cloud, probability distribution. Let me write that down. I started to here. So this is orbitals, the space around the nucleus in which an electron is likely to be found. All right. Okay. What is the atomic weight of copper? So here you need to use your periodic table to figure this out. Yeah, there's really no good way to project both the periodic table and the question up here. So hopefully you've all downloaded. I mean, you've been dealing with periodic table long enough. You should have some copy you can reference, easily accessible to you, including that PDF that for the next test. Oh, my timer never went. Oh, this is so annoying. We'll wait till the 30-second mark here, or we'll wait till we have like 12 responses. Whatever comes first. I know there's more of you out there. I know you all have cell phones. Use them for this activity. Right. 63.55 AMUs. That is correct. Let's look at just quickly the periodic table. I wrote down 63.55 AMUs. Oops. Where's my? Oh, no wonder. Hold on. I gotta separate this out, or I'm not gonna be able to flip between them easily. All right, copper. First of all, remember the key down here shows that the element name is up here, the symbol, we have atomic weight and atomic number. So copper is right up here. The atomic number is 29. This defines the number of protons present in the element. The atomic weight is 63.55 atomic mass units, AMUs, and that's found right below here. And this is, remember, this is not the number of neutrons and protons in one atom, right? This is the number, this is the statistically weighted average. So if you were to go out into nature and dig up a sample of copper that's representative of all the copper that exists in nature, it would, on average, it would consist of, copper that has, 64, 63. I don't know if there's a 65, but it would different isotopes of copper, and they statistically average out to 63.55 AMUs. So that's right here. And the atomic number of copper, we'll use the table here again. Remember I showed you it was 29. So that's the atomic number. So we'll write that there, 29. I'll just make a little note here. This is the number of protons. All right, let's go back to this thing. Sure, let's save changes. All right, next. Which component of the atom is involved in a chemical reaction? Options are pretty straightforward. Shouldn't take you that long to read them. Oh, here we are. Ooh, which component of the atom? All right, so chemical reaction. The electron. This is the outermost, remember we were always talking about valence electrons when it comes to the chemical reactions, right? When we talked about chemical reactions in the latest, chapter 9, right? The electrons are the ones that are being exchanged or shared and resulting in chemical reactions. So electron, that's the correct response here, electron. Let's go to the next one here. What does AMU stand for? This is a quick one, 30 seconds. I ran out of options at the end. And I just mentioned this one earlier. So atomic mass unit, yes. Thank you for not choosing Mr. Underpants. Atomic mass unit, that's what it stands for. How many protons are in a carbon atom? So check your periodic table there and see if you can figure out how many protons in a carbon atom. 6. That is correct. All right, we'll write that down. I'll show you the next one. All right. How many neutrons does the isotope of magnesium-25 have? Oh, that's interesting. I wrote it differently than on the paper. So if you notice on your paper, it's written with a, it's written Mg with the 25 and the 12. I think at the time I didn't know how to write the superscripts, but now I do. 13 is correct. Let's go over how many people? 6. All right, let's just go over that one real quick. All right. I wrote it here like this, but if I wrote magnesium-25, I would go to my periodic table and I'd look up magnesium and I'd see, all right, it has 12 protons, right? So the mass number is 25. The mass number is always greater than the number of protons. In the case of hydrogen, it could be equal to the number of protons, but in that case, you have no neutrons, so you don't have to worry about it. The mass number is, let's see, so remember, it's mass number neutrons plus protons, right? So that means the number of neutrons should be the mass number minus the number of protons, which I have right here. 25 minus 12 equals 13. So this has 13 neutrons. I'm just going to jump to this one here. Isotope 2512 magnesium. The alternative notation, right, is magnesium dash. Now, remember, as long as we know the element name, we can go to the periodic table and look up the number of protons, right? That's the atomic number. So we don't need the 12. So this is where you would write magnesium 25. So these two questions are kind of coupled. And then let's go to iridium. Let's go to that question there. You can answer it online. I forgot to make a note of which questions do I not have online. How many protons does an iridium atom have? So look at your periodic table and find iridium. I'll give you a clue. It's a transition element. And let me know how many protons you believe it has. Yes, 77. Let's go to the periodic table here. Iridium, right down here, 77, number of protons. What's my next one? Oh, yeah, see, I figured out how to do it by then. We already did this one. I'm not going to bother. Magnesium 25, that's the one that we did. Let's go to the next one here. Okay. In terms of how they form ions, what's the major difference between transition and representative elements? So you have to read each one of these here. Let's see. All right. So, all right, good. No one guessed this one. All right. The correct answer is up here. Representative elements tend to form one ion, and transition elements tend to form more than one kind of ion. Radioactivity has nothing to do with ions, so that's out. You can't know for certain the ions, representative elements, can form positive and negative ions. So these two are out as well. Let me write this down. So representative elements, these are the A groups. All right, so on the periodic table, we're looking at 1A, 2A, and then 3, 4, 5, 6, 7, 8A. Right? They tend to form one ion. Transition elements these are the B groups. Tend to form more than one kind of ion. Oh, something in the chat. I don't even know how long ago this was. Let's see. Oh, okay. Oh, that's not good. I hope her cat's okay. All right. We have a cat too. And I feel for the cat. Let's go back to the slides or the. Since we got some time here to do next. All right, when forming ions, transition elements typically form ions with this sign. Remember, transition elements, these are the ones we just talked about as being group B. What sign do they typically form, or what positive, negative, neutral, or Aquarius? Hey, Carbon, what's your sign? Positive, yes. Transition elements form positive ions. They tend to form positive ions. Let's go to the next one. And the elements that are grouped on either side of the dark staircase-like line are classified as what? Metals, non-metals, semiconductors, or items to go upstairs. Oh, I skipped a bunch here. I wonder, I wrote it in the wrong spot. We'll go to the sheet here in a minute. Semiconductors, yes. Your parents ever put something on the stairs hoping that someone would take it up, but it never goes upstairs? That's what items to go upstairs are. But these are semiconductors. Those are the ones in the staircase. Let's look at the periodic table here. In fact, you can see the classifications green, right? So these elements here are semiconductors. Aluminum doesn't make the cut as a semiconductor. It's more of a metal property. Let's go to the slide here. This should be, I forgot we skipped these because these were fairly easy. So all transition elements are classified as metals, non-metals, or semiconductors. The answer here is metals. Right, you can see all the transition elements are blue. They're all metals. I only wrote semiconductors because I thought I wasn't paying attention, obviously. The component of the atom that has a negative charge. I think, again, we've all seen this. I remember taking out now some repeats from the polls, but not adjusting the packet because I had already made up the packet. Let's go back to the poll here. I think we can finish up this page. Members of the group VIIIA elements have this special name. So group 8A. What are they called? This is right on the table. If you have it in front of you, it's easy. If you don't, well, you're going to have to kind of remember, I guess. We'll do this one, the next one, then we'll finish up. All right. Yeah, so the correct answer is noble gases, group 8A. Let's just quickly flip to the periodic table. Group 8A, noble gases. Right here. Oops. Gave you the answer. Wrong window. Let's just go to it. Finally, what group do the halogens belong to? And what does the term halogen mean? The halogens. We just saw the group on the periodic table. It's in there somewhere. Technically, this class goes to 11:51, so. All right, if you look at the registration schedule. right, 8 seconds. 7 people responded. Oh, yeah, so they're group 7A, and it means salt former. So we'll go to the periodic table here. Halogens, group 7A. And I just wrote this down here. So if you want to catch up on the notes here, this is the last section of page 3. Let's stop here and then we'll finish up. Well, we won't finish up on